Now I'm going to show you how to implement the VAR model in RStudio. So VAR model is one of a statistical method that is used in order to model variables, especially to set up the relationship between two or more than two variables. To run VAR model as well as vector error correction model in RStudio, we need two important packages that are T-series, which is a package that is used to if you are going to test for unit root of course. Unit root test is very important in VAR modeling because stationary of variable are required to run VAR model. So the second package that you need to have installed in your RStudio is VARs. VARs is a package that's used VAR modeling as well as vector error correction. To run your model, first of all, you need to set up your data frame. I have, for example, in my database, three variables: beta 0, beta 1, and beta 3 that I'm going to model using VAR process. So the first step is to define my data set. That is a matrix variable that are going to be used in my VAR model. So to set up my data frame, I will define my data frame as beta. So I will write here beta equal cbind. So use the command cbind to concatenate my three variables that are beta 0, beta 1, and at last beta 2. Then click on OK. You see that my data set beta is being set to run my my VAR model. So the first step in my modeling process is to run unit growth test. So the unit growth tests I will run is augmented TK-fuller test that you can also use Philippe Perron or KPSS test. We just focus here on augmented TK-fuller test using the command atf.test brackets beta 0, my variable beta 0, and then click on run. And we see that the result of our augmented TK-fuller test for beta 0 is set. The p-value is equal to 0.01, which is significant, so that we can say that our variable will reject the null hypothesis of unit root in our TK-fuller test, meaning that our variable does not have unit roots, so it is stationary. My variable beta 0 is stationary. You can also check it for beta 1 and beta 2 in order to run your unit root test. So the second step in our modeling after running unit root test is to run our VAR model. So the command to run our VAR model is to use the command var.n affectation symbol, or the command var bracket. Here is a data frame that has been defined to run our VAR model. That data frame contains the different variables that are going to be used in our VAR process. So the three variables are beta 0, beta 1, and beta 2 that are going to be used to set up the relationship. So we have number of lag that is to be put in our VAR model. I choose for now the 1 lag process. We can also use the type constant in order to tell R that in our model the constant should be taken into consideration. We have set seasonality which says to be null. Suppose that in our set there is not a matter of seasonality. You can also use exogenous command to say that there is not null for not exogenous variable. We have maximum lag is null because we already use our set the lag to be 1. We have Akaike criterion that is been going to be used. You can also use Schwarz or even an unwin criterion in order to run your VAR model. So we'll then click on run, and you can see that the result of our VAR model is computed. So to call our VAR model, I will just use the command var.n and then click on OK, and the result of our VAR model is appearing right now. You can see all three relationships that link three variables. We have first of all the relationship that link beta 0 with lag 1 beta 0, lag 1 beta 1, as well as lag 1 2 plus the constant. So we have that coefficient that have been estimated here. We also have a coefficient for beta 1 relating to show the relationship between beta 1 and beta 0 lag 1, beta 1 lag 1, as well as beta 2 lag 1, all different relationships. So as interpretation of a coefficient, that means that lag 1 an increase in beta 0. So if you take, for example, the first equation that gives a relationship between beta 0 and lag 1 of each of other variable, including beta 0, you can say that as the coefficient of lag 1 beta 0 is negative, it means that an increase in a value of beta 0 will certainly lead to the decrease at the next period of for the variable beta 1. So the coefficient of the impact of beta 1 lag loss is positive, meaning that an increase in beta 1 will certainly or probably lead to an increase in beta 0 variable in the next period of time. So we can have the interpretation that for beta 2 that have negative impact on our beta 0 variable, and also have all those interpretation for the different equation. First step for this tutorial is to show you how to predict, to forecast using our VAR model. So it's very simple. You just use the command. So my variable, that prediction of my dataset beta, will be called I call it beta predict. That is equal to the command that's used predict. So the first argument of prediction code is to show the name, to call our var model that we have called previously var.m. Another argument is a number of periods in which we are going to forecast our dataset beta 0, beta 1, and beta 2. Choose for 12 periods. So we have a monthly data that make a prediction over a year. We have also a confidence interval level, which is 95%. Also have one dummy. Say that there is not dummy that is going to be used in order to predict our model. So then we will run the command, and we can see that our variable will show different result. If beta predicts, and then click on OK. We will see that our different prediction, our different forecast of different component of our VAR model have been made. We have, for example, beta 0 that have a forecast for the next year is for the next month at 0.07744. We have the second month, we have the prediction, we have the forecast for the next 12 months that are here, which confident and interval that have the lower and the upper value. So the lower value, for example, at first year forecast for beta 0 is negative 1.14, and the upper value is 1.30. We have the interval confident interval length that is here. So we have the forecast value for beta 0, also the same thing for beta 1, forecast for the next 12 here. We also have forecast for the next 12 here for beta 2. So we hope this video have been very useful. You have not yet subscribed to the YouTube channel, do subscribe in order not to lose the next videos on different techniques on statistical model for social sciences.